There's this silent language being spoken all around us, all the time. Every single thing, from a piece of ripening fruit to a machine under stress, is constantly giving off this stream of molecular data. It's this huge, invisible layer of information that we've just never been able to read, until now. And the idea for this technology, called olfactory detection and ranging, or OdAR, is kind of funny. It actually started out as a joke for its inventor, Matt Riesinger. But that joke quickly turned into this massive epiphany he just couldn't shake. So for the past 2 years, pulling from his background in AI at Tesla, he literally taught himself the entire olfactory system from scratch. And what he developed is what we're diving into today, a truly groundbreaking system designed to give our technology an actual working sense of smell.
So here's our game plan. First, we're going to tune into that silent data that's everywhere. Then, we'll look at how nature already perfected the solution millions of years ago. After that, we'll get into the nitty-gritty of how engineers rebuilt that solution from the ground up, see how it actually gets used out in the field. And finally, we'll explore what really becomes possible when you can digitize the world of scent.
All right, let's start with the big problem. We are absolutely swimming in information, right? But there's this whole dimension of it we've been completely blind to, the chemical dimension. This is that untapped data layer that's all around us, every second of every day. And this idea right here is so incredibly powerful. It just perfectly highlights this massive, gaping hole in our technology's senses. I mean, we've got digital eyes, we've got digital ears, but our ability to smell has been stuck in the dark ages. And that's not just some small inconvenience. It's a real problem that leads to preventable disasters, missed medical diagnoses, and just huge economic losses. This table really just lays it all out. All the previous attempts to build an electronic nose have, to be blunt, pretty much failed in the real world. You can see right here, they're slow, they get easily confused by complex smells, and their sensors just drift over time, meaning you have to constantly recalibrate them, which is a total nightmare. The big takeaway here isn't just that we need a slightly better sensor, it's that we need a totally new way of thinking. So, where do you find a brand new approach? Well, you look to the one who's been doing it perfectly for millions of years, nature itself. The mammalian sense of smell is the absolute gold standard. It's a complete computational model that has already solved every single key problem we're facing in chemical sensing. And this right here is such a critical distinction. The OdAR system isn't just, inspired by a nose. No, it's a systematic, architectural translation of a proven biological computer. It's about looking at how a brain actually smells, breaking that entire process down, and then engineering it from the ground up. And biology's process is just this 4-step masterclass. So first, molecules float in and bind to a few hundred different types of receptors. But here's where the magic really happens. Any given scent activates a unique combination of those receptors, creating this incredibly complex, high-dimensional pattern. That pattern then gets amplified and sharpened by neural circuits. It's this entire pipeline that the OdAR system is built to replicate. Okay, so how in the world do you actually build a synthetic sense of smell? Well, it all revolves around one central piece of hardware, the olfactory bulb. This thing is the cognitive core, it's the brain of the whole operation, and it's built into every single OdAR device. Let's break down exactly how this thing works. So it all starts at the nanoscale with the sensing substrate. Using a process called electrospinning, they create this unbelievably dense mat of nanofibers. The best way to picture it is like a microscopic spider web, and its one and only job is to create a huge surface area to maximize the odds of catching any airborne molecules, which is a perfect mimic of the tiny little hairs, the cilia, inside your own nose. Now, this is where that combinatorial magic really kicks in. So instead of having just one type of sensor, that nanofiber mat is coated with a whole stack of advanced nanomaterials. You got graphene, which gives a super sensitive electrical signal. Its resistance actually changes. Then you have quantum dots, which add an optical layer. They change how they glow. And finally, gold nanostars provide a really detailed spectroscopic signal, which is a pattern of how they absorb light. So you see, it's not one signal, it's 3 totally different types of data, all working in concert to create this rich, multi-dimensional fingerprint for every single chemical it encounters. And to process a fingerprint that complex, you need a special kind of brain, a hybrid brain. First, a photonic integrated circuit, which is basically a computer chip that uses light instead of electricity, pre-processes all those optical signals at, the speeds of light. That cleaned up signal then gets fed to a neuromorphic processor. That's a brain-inspired chip that uses these incredibly efficient algorithms to recognize patterns using almost no power. It's the perfect 1-2 punch of speed and brain-like efficiency. Now, you can have the most advanced hardware in the world, but it isn't intelligent right out of the box. That intelligence has to be forged, and that happens here, inside the OdAR olfaction chamber, which is basically an AI foundry. The standard operating procedure is meticulous. Every single olfactory bulb is placed inside this hermetically sealed computer-controlled chamber where its AI literally builds its library of smells from the ground up. And the training inside this chamber is incredibly tough. It's not about just showing the sensor a chemical and saying, hey, this is what this smells like. No, this system puts the AI through a full-on boot camp. It learns to recognize concentration gradients, to identify those short, sharp pulses or whiffs you'd find in the real world. And most importantly, using advanced algorithms, it learns how to deconstruct really complex mixtures and surgically ignore all the background noise. So, once a sense is forged inside that AI foundry, how do you actually deploy that intelligence out in the real world? Well, this is where we see those individual olfactory bulbs become part of a much larger collaborative system.
The whole system is designed to work like a team. You have a human operator using a handheld device, they call it the cognitive scout, to get that first high-confidence detection. Okay, I've got something here. That data then guides the drone swarm, the probabilistic localizer, which takes over and autonomously searches a huge area to triangulate the exact source of that scent. And that handheld device is so much more than a simple detector. It's got the full olfactory bulb inside, with that powerful hybrid brain, so it's doing complex analysis right there at the edge. It even has these tiny micropumps for active sniffing, so it can literally draw in air samples just like an animal would. And every single reading it takes is geotagged with high-precision GNSS, creating this incredibly detailed scent map as the operator moves around. The drone swarm is just a marvel of decentralized intelligence. It actually uses different types of drones for different jobs. Some are scouts, others are executors for detailed analysis. It can even navigate in places with no GPS, like a dense forest or a city, by creating its own ultra-wideband positioning network. And here's the really brilliant part. It uses a process called Bayesian inference, which is a way of updating its beliefs as it gets new evidence to collaboratively build this probability map of where the source is, updating it in real time as each drone sends back more data. So, now that we have this incredibly powerful new sense, what can we actually do with it? Let's explore the real-world impact of finally being able to digitize the world of smell. In defense and aerospace, the implications are just staggering. Think about it. Traditional stealth tech is all about being invisible to radar and infrared, but every single propulsion system, whether it's a jet engine or a submarine, leaves this invisible chemical trail behind it. OdAR could be trained to track those unique chemical signatures, making it possible to detect and follow targets that are completely invisible to our entire existing sensor network. For industrial safety, this technology creates a fundamental shift from being reactive to being proactive. Right now, alarms usually go off after a pipeline has already failed. But imagine a swarm of OdAR drones just autonomously patrolling hundreds of miles of infrastructure 24/7. They could detect those tiny parts per billion microleaks that are the very first signs of trouble, giving a warning long before a catastrophic failure. And in medicine, my gosh, OdAR could finally unlock the dream of non-invasive diagnostics just by analyzing your breath. We know that many diseases, including some cancers, produce unique chemical markers. The problem has always been finding those faint signals in the noise of a breath sample. OdAR's unique ability to deconstruct complex mixtures could make pre-symptomatic screening for deadly diseases a routine, affordable reality. And in agriculture, this is the start of a whole new era of precision farming. A plant that's under stress from a disease or a pest emits specific chemical warning signals way before you'd ever see any visual signs like yellow leaves. OdAR can essentially hear these first chemical whispers, letting farmers apply treatments only to the specific plants that need it. That could save entire crops, boost yields, and dramatically cut down on our use of pesticides. When you really think about it, OdAR isn't just a new tool. It's an entirely new channel of information. It gives us a way to finally listen in on this silent conversation that has been happening all around us this whole time. And it leaves us with this one fascinating question. Now that we can finally listen, what secrets is the world finally going to tell us?